Hello students, last class we have discussed with the methods of preparation of alcohols. Let us continue with the properties, the physical properties at first. Now these alcohols consist of two parts. One is the alkyl group R and the functional group hydroxy group OH group. Now the boiling points of alcohols are high because of intermolecular hydrogen bonds. You can just see the representation there of intermolecular hydrogen bonding between the molecules of alcohols. Now the other physical property is that though they are organic compounds, they are completely miscible or soluble in water. This solubility in water is a special feature of alcohols, and it is the ability to form hydrogen bonds with water molecules which makes alcohols soluble in water. You can just look to the dotted lines there which indicates the hydrogen bonds. So these are the two important physical properties of alcohols which you need to remember. They are completely miscible in organic solvents. Now coming to the chemical reactions or chemical properties, the first set of reactions are reactions involving cleavage of OH bond. OH bond is nothing but the hydroxy group, OH group, the bond between oxygen and hydrogen. A very important reaction is that of reaction with metals. Yes, metals like sodium and aluminium. Metals like potassium, aluminium, sodium, etc. displace hydrogen from the alcohol, forming corresponding alkoxides. Now remember, R represents the alkyl group. R with oxygen, RO minus, is called as the alkoxide group. So therefore RONA will be the general formula of a sodium alkoxide. The general equation given here is alcohol reacts with sodium metal to form RONA, sodium alkoxide, and H2 gas is displaced or liberated. One particular example mentioned for you all is that of the reaction between tertiary butyl alcohol. Now this tertiary butyl alcohol also has the IUPAC name as 2-methyl propane 2-ol. Reacts with the aluminium. So aluminium is Al, to give the product as aluminium tertiary butoxide and displacing hydrogen H2 as gas. So if you look to this particular reaction, to balance it is 6 molecules of tertiary butyl alcohol and 2 aluminium, so that you will get aluminium tertiary butoxide with the liberation of hydrogen 3H2 as a gas. So this is the reaction on the basis of which we discuss another characteristic property of alcohols, which is nothing but acidity of alcohols, acidic nature of alcohols. Now alcohols are acidic in nature because of the polar nature of OH bond, that is oxygen being more electronegative than hydrogen. Now the polarity of OH bond will decrease with increase in the electron density on oxygen. So therefore, if you compare the primary, secondary and tertiary alcohols, now this is RCH2OH is a primary alcohol. So this will be RCHR-OH is a secondary alcohol. RCR-ROH is a tertiary alcohol. It is found that primary alcohol are more acidic than secondary alcohols than tertiary alcohols. This is very important. And alcohols are weaker acids than water. If you compare alcohol with water, so it is found that alcohols are weaker acids than water. Look at the general representation of the base which is formed, RO minus, due to the liberation of proton from alcohol. RO minus picks up a proton from water, H2O. Yes, so RO minus will pick a proton from water, so that you will get ROH and OH minus. Now if you look to this particular equation, Here RO minus alkoxide ion is a base, water acts as an acid, and the alcohol formed ROH will be the conjugate acid, whereas OH minus will be the conjugate base. Now you must be familiar with what is the meaning of the term conjugate acid base pair. An acid base pair which differs by a proton. Look to RO minus and ROH. They differ by H plus. That is called as a conjugate acid base pair. Similarly, water H2O and OH minus. So they form another pair of conjugate acid base which differ by a proton. So an acid base pair which differs by a proton is called as a conjugate acid base pair. Now this is regarding the acidic nature of alcohols in detail. Now coming to a very important reaction answered by the alcohols, a named reaction called as esterification reaction. The reaction is called esterification reaction, in which carboxylic acid, the general representation of a carboxylic acid is RCOOH, reacts with an alcohol R-OH in the presence of concentrated sulfuric acid. If you look to the reaction equation there, OH from the carboxylic acid and H plus from alcohol is being eliminated as water. So essentially a dehydrating agent is to be used. The dehydrating agent used is concentrated sulfuric acid. And whatever remains, look to the formula there, R C double bond O R dash is the general formula of an ester. The product formed is an ester with the liberation of water molecule. Now other than the carboxylic acid, you can also take an acid anhydride. Remember, an anhydride is obtained by the elimination of a water molecule from the corresponding two molecules of carboxylic acid. RCOOH and RCOOH, two molecules, eliminate H2O. You will get RC double bond O twice O, which is nothing but an acid anhydride. Acid anhydride once again reacts with an alcohol R-OH in the presence of acid media H plus. The product formed is ester, but the byproduct formed will be a carboxylic acid RCOOH. Now the other reaction of obtaining an ester is by taking an acid chloride, that is OH from the carboxylic acid RCOOH is replaced by Cl, so that you will get an acid chloride RC double bond OCl, reacts with an alcohol in the presence of the heterocyclic compound, that is pyridine C5H5N. Once again the product formed is an ester RC double bond OR dash, and the byproduct formed will be HCl. So all these three wherein the product obtained is ester represent the esterification reaction. So this is a very important reaction usually asked in the examination. Do remember it. Now this is the first set of reactions. Now the second set of reactions are the reactions involving cleavage of carbon-oxygen bond in alcohols. Now if you look to this particular set of reactions, reactions involving cleavage of the carbon-oxygen bond in alcohols. Just look there, I have mentioned only the names of the reaction. The first set of reaction is reaction with halogen acids. Second set of reaction is reaction with phosphorus halides. And the third is reaction with thionyl chloride. Do you remember where we have come across these reactions? We have come across these reactions in the topic haloalkanes and haloarenes. So 1, 2 and 3 reactions have been discussed in the previous topic, haloalkanes and haloarenes. So these are repetition reactions. You need to write the reactions once again, though they are repetition reactions. Now in this particular set, that is the reactions involving cleavage of carbon-oxygen bond, the next reaction is an important reaction wherein you will be discussing with the mechanism too. It is called as acidic dehydration, a very important reaction. So mechanism is usually asked in the examination. Let us first look to the reaction of acidic dehydration. Now I have represented the alcohol in a general form, that is, there are two carbon atoms, alpha carbon and beta carbon. At first, let us see what is acidic dehydration. It is nothing but an elimination reaction which is carried out by heating the alcohol in the presence of concentrated sulfuric acid. So if you look to the general representation there, H plus from beta carbon and OH minus from alpha carbon is eliminated as H2O, and the pair of electrons between the CH of beta carbon shifts to the adjacent position and you will get the product as an alkene. Double bond is introduced between the two carbon atoms with the elimination of a water molecule H2O. So this is the general representation of the reaction. I hope the general equation is clear. Remember, for the elimination reaction, presence of beta hydrogen in alcohol is essential. Then only the product formed can be an alkene. So hydrogen cannot be eliminated from the same alpha carbon from which the OH group is eliminated. To take one particular example, that is the acidic dehydration of ethanol. I have written the structure of ethanol in the expanded form so that you will understand what is alpha carbon and beta carbon. Now ethanol on heating in the presence of concentrated sulfuric acid at a temperature around 443 Kelvin. Just look there, OH from alpha carbon and H from beta carbon is eliminated as water and shift in the position of pair of electrons of CH bond with the adjacent carbon atoms will give you the product as CH2 double bond CH2, that is nothing but ethene with the elimination of H2O. Yes, so this is the reaction equation. Now you need to discuss the mechanism of dehydration of ethanol. So if you look to the structure of ethanol in the expanded form, the oxygen atom has two unshared pair of electrons or lone pair of electrons. The first step is formation of protonated alcohol. So this protonation takes place by the oxygen atom which picks the proton because it has unshared or lone pair of electrons, so that a positive charge will be introduced on the oxygen atom. Now the product formed will be protonated alcohol, which is also called as ethyl oxonium ion. So the positive charge is introduced on the oxygen atom. So this is a fast step, step 1. Then the second step is, yes, if you look, this is the same ethyl oxonium ion or protonated alcohol. Now this is the slowest step wherein the formation of intermediate carbocation takes place. That is, oxygen being more electronegative pulls the electron pair of carbon-oxygen bond towards itself, so that a positive charge is introduced on the adjacent carbon and water is eliminated. So that you will get ethyl carbocation intermediate and water is eliminated, H2O. Now this ethyl carbocation which is formed, CH3 CH2 plus is an ethyl carbocation, will eliminate a proton in the last step. If you look at the last step there, yes, this is the ethyl carbocation, will eliminate a proton, so that shift in the position of pair of electrons towards the adjacent carbon takes place and you will get the product as ethene, CH2 double bond CH2 plus H plus. Now if you look there, the proton which is liberated H plus can be once again utilized in the first step there for protonation until all the alcohol molecules are converted into alkene, that is ethanol is converted into ethene. So these are the 3 steps involved in the mechanism of acidic dehydration of ethanol. Now, usually this mechanism is asked in the examination, so you should not only read the mechanism, the way to remember it properly is to write and practice. Even if you miss a positive charge or miss a pair of electrons on oxygen, you will not get marks. Be very careful while you are writing the mechanism. So just like mathematics, you need to write and practice the reactions and mechanisms. Only oral reading will not help to remember and understand the reaction equations as well as the mechanisms. Now another last set of reactions are there, that is oxidation reactions, which I will continue in the next class. Thank you.